Everyone. Oh, try that again. Welcome, everyone. We're so happy to have you here. Today, we're going to share a little about our new solar toolkit that came out. It has three parts to it, so we'll share each of those with you. And we're going to kick off with just a little introduction. One second, see if I can get this. Are you seeing my slides all right?
Yeah.
Great. Oh, too far. This is us. I want to introduce the team from NASA Heat. We've got Michael Kirk with us and Carolyn Ng, and these two are the impetus for why this whole toolkit came together. And I want to give a big shout out for NASA Heat and their whole team for everything they do to get us enjoying the sun all the time. A lot of their materials we'll be highlighting a little later, and I just wanted to say thank you so much. We'll be hearing from both of them tonight. And then here at the Astronomical Society of the Pacific, my name's Vivian White, and we have Brian Cruz here with the sun in his background, and Kat Troche with the beautiful sunset. And we're just real pleased to have you here. So I think, Michael, you're up first.
Yeah, absolutely. Thanks for the introduction. I come to you from NASA's Goddard Space Flight Center, where our education team, the Heliophysics Education Activation Team, NASA HEAT, where our job is to talk to people about heliophysics. Heliophysics, made up of two words: helio, meaning the sun or the study of the sun system, and physics, meaning the study of how things work. So heliophysics is a word that was coined by NASA just about 20 years ago, and we're working to get more familiarity with the word. It's a big word, but Tyrannosaurus Rex is a big word. My 3-year-old can pronounce it better than I can, so heliophysics is not too scary once you break it in. But this is a great picture of what heliophysics is practically, which is the sun's effect on the Earth and the entire space system. So if you want to go on to the next slide. This is where I roll the dice and hopefully an animation will play. Maybe. Okay, it's coming in. All right, a little jerky, but this is an animation that we had commissioned a few years ago to try and illustrate all of the different aspects of heliophysics, which is the sun and the eruptive processes on the sun, and how those move through space, and then how they affect the Earth. And how NASA studies these things using a fleet of satellite called the Heliophysics System Observatory. This observatory is not your conventional observatory where it's just one satellite, but it's made up of a whole fleet. So you'll see Parker Solar Probe right there at the center, right at the beginning, flying through the atmosphere of the sun. It's had its closest approach in December of last year. And then you'll see both Voyager, sort of an intermediary space as we zoom out, and then a generic constellation of Earth's viewing satellites that was supposed to be the GDC mission, but GDC mission's a little bit tentative on whether that's actually going to be made. So stay tuned for that. Maybe go on to the next slide. Yeah, Google Slides is very sticky about its presentations. Like it really wants you to watch all of the videos. All right, so heliophysics at Goddard is made up of really three different components. One is the exploration component, trying to understand the impact of solar phenomenon on Earth and space environments, including satellites, including astronauts in space, especially once they leave the protective Earth's magnetosphere. But also understanding that space weather in itself, understanding how storms move through interplanetary space, how they evolve, how magnetic clouds change dynamically, and how they affect our technology here. Anybody who has been around long enough may remember a solar storm from the late 1980s, which took out the power grid in eastern Canada. And this sort of space weather effect happens now as much as as much as back then, except the difference now is that we're mostly tuned on the power grid side, but not on the satellite side. So there are plenty of new satellites going up, and a lot of those are deeply affected by space weather and by different atmospheric drag components caused by the sun's emissions. So trying to understand that's one of the key components. And finally, working to help engage the community, both the scientific community and all of you, with understanding how these processes and these systems work and how they affect our everyday life. And so that's where NASA Heat comes in. You want to go on to the next slide? I think that's my last slide. So what we do is our team is that interface between the laboratory of Goddard Space Flight Center and the public. So we're develop educational resources with formal education alignments. So think classroom grade 5 banded materials so that teachers can use them in the classroom to teach about fundamental science concepts, but using the sun or heliophysics as an example. We also look to connect to missions. We want to understand, want people to understand why NASA needs to launch yet another satellite. What is it studying, and how does it actually affect my life? And so understanding that interplay between mission data and then once the data comes down, what we do with it on the ground is part and parcel to what we do and how to understand that data. We do that through casual sort of informal events as well as formal curriculum. Community building is a large part of what we do, working with partners, both domestically, like the Astronomy Society of the Pacific, as well as international partners to come together and help educators understand how they can teach about heliophysics, integrate math resources into heliophysics, or do understand how you incorporate formal education or informal education. And finally, the educational engagement, doing professional development, looking at how do we help educators, both formal educators like classroom teachers or college professors, or informal educators like 4-H clubs or after-school programs or community libraries, help them not only think about the sun, but actually get excited when something happens on the sun, like there's a new solar storm. So that is NASA Heat. That's what we do. I'd encourage you to go visit our website. You can easily find it by Googling NASA Heat, or if you go to science.nasa.gov/learn/heat, it'll dump you off there. We have plenty of resources online. So happy to answer any questions in the chat because I think it's a full program tonight. So I don't want to take any more time. Yeah, thanks, Kat, for putting that in the chat.
No worries.
All right. Thank you so much, Michael. And Carolyn, you want to say hello? You have been a huge part of this, and I just want to make sure you're here too. We appreciate all you do.
Oh, thank you, Vivian and Kat. Carolyn Ng here, a contractor at NASA Goddard, working closely with Michael and the team to promote heliophysics education and doing informal engagement. Thanks.
Yeah, so
Thanks.
Carolyn is our lead for engagement. So if you have a program that you just think could use a sun ray shining in on, I don't know what metaphor I'm looking for, but want engagement, Carolyn is the person to talk to. She knows everybody.
That is true. If you need anything done, Carolyn is the one to ask. So thank you. I know most of you here are members of the Night Sky Network. I think maybe even all of you, but this will be recorded. So if you are just finding the Night Sky Network, we do quite a bit of public engagement with amateur astronomers across the country and around the world. This is where you can find the Sun Toolkit we're going to debut in just a moment. And I wanted to mention that these are new resources, but we have an amazing Our Magnetic Sun toolkit that this was somewhat based on, and we have all of those resources still up there. Lots of activities on, where does the energy come from? A whole list of activities. So you can find all of what we're going to talk about tonight, as well as those resources on this bit.ly right here, Sun Toolkit. So I will not spend too much time on that, but feel free to ask questions there too. And our first resource that we're going to share with you tonight are these sun cards. And I think, Kat, are you taking that one on?
That is Brian.
Oh, Brian, hit it.
I think that was me. So we spent a great deal of time, and the number of iterations of these that we went through in basically the last 9 months was amazing. And we sent it out for review, and people would come back with comments. We discovered we'd have to redo them entirely, and then we'd send it out for more comments, and then we redid it. I think we went back to scratch about 3 different times before we finally settled in on this. But we like this image on the front showing the sun in a variety of different wavelengths, and it really shows that we need to look at the sun in a lot of different ways to be able to really understand the dynamics of what's going on. And so let's go to the next slide. And so this is the back of the slide. And so these slides have the front and the back. Usually the back is something that relates to what was going on the front. We have some hints about things in the Ask, Don't Assume there. And so this is something that you can certainly take a look at in more detail. We had a lot of imagery. Some of you might have discovered that one of the cards was missing an image on the back. And so you hopefully noticed that in the envelope that you got, there was a folded piece of paper with a letter that Vivian put together. And in there was a sticker. I don't remember which card it was, but that goes on, I think it was the back of card 9 or something like that. So we can look that up. So there is one of the cards that's missing an image on the left-hand side. So let's go to the next slide.
I just add that on the PDF that's available online that you can print yourself, the image is there.
Yeah, that one we managed to fix in time. So we kind of start off, we try to have some hints here, or some entrees into thinking about this. What are some I guess conversation starters, I guess you might say. And so, what color is the sun? And at sometimes, like at sunset, it looks very yellow. The one behind me here, behind me is actually at sunrise. It's an unfiltered, unless you want to call tule fog in the California Central Valley to be a filter, and that's with the 500 millimeter lens. And so it blew up quite nicely, and there's some really big sunspots on there. And so that's one way that you could, use and look at the sun safely. So what color is the sun? And then on the back, we did this for a couple of these cards, and this is one of our favorite things. And so here you see a flashlight, and if you take a couple of glue sticks, hot glue sticks, they're pretty much clear. They're a little bit translucent. And if you shine this flashlight through these, you can see how the color changes as there's more and more of the glue stick to refract the light, to scatter the light. And it's almost like what happens when the sun gets lower and lower at sunset, or as it's just rising in the mornings. And so this is a good way that you can put this in people's hands and get them to experience what is going on during a sunset or a sunrise, where the light is going through a great deal more atmosphere. So this is something that we tried to incorporate in some of these. So let's go to the next slide. So, and then, what are those dark spots we see on the sun? And so this is another way of eliciting a conversation with your audience as they come visit you. And then let's go to the back of that card. And on the back, we have another hint of something that you can do. On this one here, you might notice that it looks like the little gray strips that are in the white lines look darker than the ones that are put on the dark ones. But it turns out that all of the lighter gray strips are actually the same color. And this is one of the reasons that sunspots look darker. If you were standing right next to it, it would be very, very bright, but it's only dark in comparison to its surroundings within its context. And so this is another way that you can help your audiences understand another little bit about the phenomena that we can observe on the actual sun. And again, we have some information here. We have check this out, some little kind of factoids or some wonderments about what is going on with the sun, or some ways in which we study the sun. And I'm not sure what the next slide is, but it might be the banner. And this is Kat.
Okay, so I'm going to cut my camera back on. All right, and then I'm also going to ask for a little assistance from my handy dandy light here. Ooh, that's bright. So this way you all can see the banner a little bit better. All right, so we came up with this banner. It's super portable, super lightweight. You can fold it up, you can ball it up, you can throw it straight into your car or a bag, whatever you like to do. But we were able to kind of turn it into a wedge where you can see the sun in various wavelengths of light. This is especially good because if you have a telescope like I do, and you have a white light filter for your telescope, you can then point to the banner and say, oh, it's, we're showing you white light and it's just like this type of telescope, except that this is taken from space. But this is what you can see, all of these features on the face of the sun. You're able to see all of these sunspots. Now, if you have a hydrogen alpha telescope, you can also then point back to the banner and show the hydrogen alpha features on the banner and show off all the prominences and all the filaments. So it kind of gives you almost like a dual concert of being very engaging so that people can actually look up close and see the sun in different wavelengths of light. Of course, there's also ultraviolet, there's X-rays. And then on this side here, we have the auroras that you would typically see on Earth, just on other planets. And we also have our Earth to scale. I really like this banner. I'm so glad that it turned out the way it did, simply because not only is it portable, if you're like me, portability is key, but also with the image of the sun this large, it's really good for low vision observers that want to learn, but maybe they have a hard time looking through the telescope. So at the very least, you can give them an idea of what they're seeing.
I want to make one comment about this banner, and it was kind of a serendipitous thing. We're all ready to set it to the printers, but there was one little thing that we had to correct. And then in that interim, all of a sudden there's an image of auroras on Neptune, something that was brand new. And so we were able to actually add that to the banner at the very last minute, just a day or two after the image came out. And so it was serendipity that we were a little bit delayed, but we were able to actually keep the banner as current as possible because of that.
Another bonus feature on this banner, if you have somebody who is super interested and wants to learn more, and again, this is just at an outreach event, or maybe you have a librarian or you have a teacher, all they have to do is scan this QR code down here at the bottom of the banner, and it'll take them to the toolkit on our website, and then they can download all of the resources themselves.
Yes. So Greg says, can you make a banner card with just the sun minus the planets? Ooh, that would be fairly easy at this point. Possibly. Maybe we can see if we can make a extra version that just is square, maybe?
Well, one of the things that you can do, because the file, and it's a very large file for this, is available on the website. So you could take it and you could certainly edit it down and crop it down, I suspect, and then print out what you wanted from it. And so, I think that we can say that people have license to do that if they wish.
Absolutely. Yeah. These are all to be taken and done with as you like. A lot of these are great to use at outreach events when you're at the telescope, but you can also use them when you're not at the telescope at a table or something like that. Solar.
Or
Oh,
if
go
you're
ahead.
clouded out and you're indoors.
Mhm. Right. When the sun is missing in action for your solar event. Right. Good call. Thanks, Kat.
Thank you.
And then the very last product that we put out with this toolkit are a set as a slide deck, and they come as a PowerPoint or a PDF or a Google slide. So you can access them in any way that you like to use PowerPoints. You can also, or slide decks, you can also edit these to include what you like. And there's a slide at the very end that will tell you that you can use to, add your club's information or whatever else you might like. It's all on there. All right. So, and these are here to kind of help us engage our audience in a way, especially if we're all sitting down. One of the things we like to do is ask them to imagine, like, close your eyes for just a minute and imagine the sun. And what do you think of when you think of the sun? And for me, I have to count to 5 or so before talking again. Just to give everybody a minute to imagine what they think of the sun and get solicit ideas from the audience. What do you all think of when you think of the sun?
The sunburn I'm going to experience after.
Yes, right, absolutely. Sun,
Photosynthesis.
yes, good call. Anybody else?
Energy.
Yeah, a lot of energy, heat and warmth and
Weather.
yeah, weather. I am so excited that it's almost the summer solstice, so I hope you get to use these for that. So each of these have some notes on the bottom about things you might possibly want to say, or you can make it up as you go along. You can mix and match these at will. But sometimes it's really good to, depending on your audience, to kind of put in perspective what we're talking about when we're talking about the sun, that there's only one star in our solar system, and it is our favorite star, the sun. And here we are, the Earth orbiting the sun, and the sun is just one of billions of stars in our Milky Way galaxy. So this kind of orients us to where we are. The sun on this, the first picture on the left is not to scale, but it just gives you an orientation. And then the picture on the right, if it were to scale, we couldn't even see the sun on here. We'd be so tiny. So the sun is just one of many stars, and most stars now we're finding have a whole host of planets around them as well, which is pretty exciting. So our star is very important to us, but not a particularly unique star as far as they go. And this again gives us a chance to talk about what we can see from Earth. It's got quite a few different things you can share. This is a nice one just to have up if you are doing some sort of observing, talking about prominences, what they look like in an H alpha in an H alpha telescope, like Kat was saying before, but also what they look like during an eclipse, which is quite exciting. This pink, I'm sure many of you got to see, I hope many of you got to see some prominences during this last total solar eclipse. And again, we have the scale of the Earth on there as well. These are just a few of the slides that are in the slide deck. I believe it has 11, and plus some extras at the end. So talk a little bit about the sun's effects on our solar system, how we see this beautiful aurora thanks to the solar wind, and what is creating that. You can talk some about that. Again, it doesn't happen just on Earth, but it happens, the sun's effects reach far beyond our solar system and affect all the planets within it. And this is a really lovely one because the link right here on the bottom is one that you can see all of the different images from the SOHO satellite. And those will show you what the sun looks like basically right now. There are some exciting things happening on the sun today. I've gotten 2 aurora alerts in the last 2 days, which is super exciting. Has anyone gotten to see any aurora in the last 2 days? I did not. It's been cloudy here, so
Yeah.
see anything. Okay.
Yeah.
Well, maybe if you're very far north, you got to see some from this most recent outburst, but you can show how what the sun looks like from space and why we use space telescopes, because these are images that we cannot see on the ground. And that is actually most of what we wanted to talk about today. We just wanted to introduce these to you, have you take a look at them, and then in a minute we will turn the recording off and we can just chat about what you do during solar observing. We have all these great pictures that Kat grabbed from some of the events that you've shared with us. Thank you so much for sharing your events. It really shows NASA all that you are doing and lets them know how important you are to your communities. These are some great solar observing pictures that we've collected recently. And I just want to say thanks to all the clubs out there. If you are watching this later on, go find your local astronomy club. They're doing wonderful outreach, and I think you'll enjoy it as much as the people on these slides do. And I think with that, we'll turn off the recording and we'll just open it up and we can talk, have questions, and maybe talk about some of the ways that you all do solar observing and what it is that you love to share through your solar telescopes or in general about the sun.